This call is now being recorded.
Students, can you hear me?
Good morning, sir. Request
Good
accept
morning.
చేయండి సార్ వేరే వాళ్ళ.
In the today's class, I will discuss about image impedance, characteristic impedance, image transfer constant or propagation constant of T, L and pi type two port networks. Okay, I think you have already idea about this image impedance, characteristic impedance and image transfer or propagation constants. We have already derived and discussed about these 3 points. Okay, in the today's class, I will discuss about image impedance of T type two port network first and then we'll go further, right, if time is there. Okay, in the last class, what I have discussed, can you tell me? In the last class or day before yesterday's class? Do you remember? Zeros and poles. Hello? Students, answer me. Just unmute yourself and answer. Can you hear me?
Yes, sir.
Okay, last class em chesam manam? In the last class, what
Poles
have
and
discussed?
zeros.
Poles and zeros. Any doubt is there? Any doubts are there on poles and zeros?
No, sir.
No doubt, right? Just I will begin this image impedance of T-type two-port network. Okay, let us consider a T-type two-port network. You know, discuss about image impedance. Image impedance. So for any two-port network, there will be two image impedances. We have already discussed in the earlier classes. So let us consider a T-type network now, having three impedances. Let this be ZA, ZB, and ZC. They are in the form of T, is it not? If you look at that figure, it is in the form of T shape, T shape, right? This one is port 1 and this one is second port, port 2, 2 dash and 1 dash. Two terminals are there, put together called as a port. Here also two terminals are there, positive and negative. Okay, put together we call it as a second port. Okay, in the image impedance for finding, this is ZI1 is the image impedance of this two port network looking at the first port, okay, and connecting, that means loading ZI2 in the second port, ZI2 in the second port, okay. And another image impedance is by loading ZI1 at the first port, we will find ZI2 from the second port. So let us load. So this is first port. Already said this is second port. Then where we should load the impedance now for second image? Tell me. Be active in the class. Anyone tell me where it should be loaded? That is to connect it to the which port? First port you have to connect the load now. That is nothing but ZI1. ZI1 and looking from the second port you find out ZI2. Okay. Let us find out ZI1 and ZI2, which are the image impedance of the of these two port networks. ZI1 is the image impedance of this T port network, and ZI2 is the image impedance of the same T port network. Okay, T type two port network. This ZI1 is equal to, how to find out ZI1? How to find out ZI1? So we are looking at the first port and finding ZI1, right? So current will be flowing from this direction. Current will be flowing in this direction. So here it is split into two currents. So from this end we have to start calculating the impedance now. Since the same current is flowing through ZB and ZI2, so we have to add these two now, ZB plus ZI2. For finding ZI1, I am looking at the first port. Okay, so current is flowing into the port, into the network. So coming to this ZB and ZI2, current will be same current will flowing through ZB and ZI2. So we have to add these two, ZB and ZI2 should be added. And this result is in parallel with ZC. Okay, it is in parallel with ZC, and this combination is in series with ZA. Okay, this is the way of finding ZI1. Okay, I followed this, students? I followed. Just simply keeping quiet. Say yes or no?
ఎస్ సార్.
మీరు ఆన్సర్ చెప్పండి, అడిగితే ఆన్సర్ చేయాలి, లేకపోతే మీరు యాక్టివ్ ఉన్నట్టు కాదు కదా. Are you following this? ZI1, how we are finding ZI1? Looking at the first port. From the first port, we are finding ZI1. So from the second port, current is flowing from first port. So we have to calculate the resistance from the second port onwards. Okay. So from the second port, if you see ZB and ZI2 are in series, I have written here, and this combination is parallel with ZC. I have denoted here by parallel lines. Plus it will be in series with ZA. Now find out the ZI1 now. ZI1 is equal to, these two are in parallel. So ZB plus ZI2 into ZC by ZB plus ZC plus ZI2. Okay? Plus ZA. Plus ZA. Okay? Now cross multiplying by 1, let us say. So 1 into RHS and this denominator multiply with the LHS. Then you will get ZI1 into ZB plus ZC. I am considering these two terms, ZB and ZC. That is ZI into ZB plus ZC plus ZI1 into ZI2 equal to ZA ZB plus ZB ZC plus ZC ZA plus this denominator is multiplied with ZA and then numerator is added. Denominator will be same. It is moved to LHS. So here it will be ZA ZB plus ZB ZC plus ZC ZA plus ZA plus ZC into ZI2. Okay. But after simplification, this will be equal to this ZA ZB plus ZB ZC plus ZC ZC ZA can be written as sigma ZA ZB in the compact form plus ZA plus ZC into ZI2. Okay, let this be equation number 1. Okay. And ZI2 is equal to, let's consider that network ZI2. ZI2 I will again draw here for ZI2. ZI2, we have to terminate here this ZI1. ZI1, this is ZA, ZB, ZC. So looking from the second port, the Zi2 will be equal to Zi1 plus Za, or Za plus Zi1. This will be in parallel with Zc, and this total combination will be in series with Zb. Is it not? Plus Zb. So after simplification, the Zi2 will be equal to, after simplification, this equation will be reduced to Zi2 into Za plus Zc, and here Zi2 into here Zb plus Zc we will get Za plus Zc we are getting, plus Zi1 Zi2 is equal to sigma. Here we got Za Zb else we will get Za Zb plus Zb plus Zc. Here in the previous, in the first equation we got Za plus Zc. Here we will get Zb plus Zc into Zi1. This is equation number 2.
Hello, sir.
Yes?
See you waiting, sir.
Admit chese kada. Okay, this is first equation, this is second equation. I will again write the first and second equation so that we can derive from the two equations easily. So I am writing here the first equation, that is Zi1 into Zb plus Zc, Zb plus Zc plus Zi1 Zi2 equal to sigma Za Zb plus Za plus Zc into Zi2. Okay? This is equation number 1 and this is equation number 2. So from these two equations, let us find out Zi1 and Zi2 in terms of Za, Zb and Zc.
అవుతుందంట ఇంకా ఏంటి విశేషాలు చెప్పాలి నువ్వే.
మ్యూట్ చేసుకొని మాట్లాడుకోండి. These are the main equations now. Za1 into Zb plus Zc plus Za1 Za2 equal to sigma Za Zb plus Za plus Zc into Za2, and Za2 to Za plus Zc plus Za1 Za2 equal to sigma, and so on. These are the two equations. From these two equations, let us find out what is Za2 and what is Za1 Za2. So first let us add these two now. We simplify as further we can simplify it as this can be written as first one Za1 Za2 plus Zi1 into Zb plus Zc. Okay, as it is I am writing here. I am bringing to left side now. Okay, minus Za plus Zc into Zi2 minus sigma Za Zb equal to 0. Let this equation number 3. Any confusion? Students, any confusion is there? Yes. This equation, after simplifying this, that means moving this right terms in the RHS to the LHS side. We got this Za1, Za2 as it is, Za1 into Zb plus Zc. I have brought this to left side. Okay? Za plus Zc, that is minus Za plus Zc into Za2 minus sigma Za Zb equal to 0. Let it be equation number 3. And similarly, the second equation can be written as Zi1 Zi2 Zi1 Zi2 plus Zi2 into Za plus Zc. Za plus Zc. Zi2 and Za plus Zc, bringing to left side this one. So minus Zb plus Zc into Zi1 minus sigma Za Zb equal to 0, fourth equation. Okay, let us add these two now. If you add these two, you observe what are the terms that will be cancelled. If you add these two, Zi1, Zb plus Zc, these two will get cancelled. Za plus Zc, Za plus Zc into I2, and Za plus Zc into I2. So these two will get cancelled. Finally, we will get 2 into Zi1, Zi2 minus 2 into sigma Za Zb equal to 0. Okay, what is sigma Za Zb? Can anyone tell me? What is sigma Za Zb? What is sigma Za Zb? What is sigma Za Zb? Sigma Za Zb is
Zi1 plus
sigma Za Zb అడుగుతున్నా.
Zi1 into Zi2.
కాదు. Sigma Za Zb is nothing but Za Zb plus Zb Zc plus Zc Za. This is sigma Za Zb. This is the compact form of this. If you expand this, you will get that. In the expression, I have just written the compact form. The sigma Za Zb is nothing but Za Zb plus Zb Zc plus Zc Za. So first step లో చూడండి అవి. First expression, Zi1 is equal to, we have found that equivalent impedance of the network. Okay, in that expression, you will find these terms Za, Zb plus Zb, Zc plus Zc Za. Okay, all these are put in the compact form as sigma Za Zb. Okay, I follow now. So these are the main equations, these two. Okay, from those expressions I have found these two equations. These two equations again further written in a proper way. Okay, in this form, third and fourth equation. Now I have added these 3 and 4 equations. Then if you add, we will get this expression now. This equation. Let us name it as equation number 5. So 2 will get cancelled. Finally, it will be Zi1, Zi2 minus sigma Za Zb is equal to 0, or it can be equal to, or Za1 Za2 is equal to sigma Za Zb. I followed this. If you add these two equations, you will get this equation. I am writing equation 4 from equation 3. The first one we added 3 and 4, right? Equation 3 and 4 are added. Now equation 4 is subtracted from equation 3. If we subtract, what are the terms that will be cancelled? Za1 Za2 will go off, and sigma Za Zb will go off. Okay, so finally we will get, to subtract 4 from 3, you will get 2 Zi1 into Zb plus Zc minus 2 Zi2 into Za plus Zc equal to 0. Okay, finally it will be reduced to Zi1 by Zi2 is equal to, by equating and dividing by 2, you will get Zi1 by Zi2 equal to Za plus Zc by Zb plus Zc. Let this be equation number 6. Okay, followed students? Okay, let us consider this 5 and 6 now. 5 and 6. Okay, then how to find out Zi1 and Zi2 from these two equations? Can you tell me? Anybody tell me? Zi1, Zi2 is equal to sigma Za Zb, and Zi1 by Zi2 is equal to Za plus Zc by Zb plus Zc. Zb plus Zc. To multiply these two equations, Zi2 or Zi2 will get cancelled. Get Zi1 square equal to Za plus Zc by Zb plus Zc into sigma Za Zb. Okay. Just see the notes. Are you following or not? By multiplying 5 and 6, to multiply this term with this term, what will happen? Za2 will get cancelled. Za1 and Za1 will be Za1 square. Okay. So multiply these two, Za2 will get cancelled. Za1 into Za1 will be Zi1 square is equal to, and RHS also you have to multiply the terms now. ZA plus ZC by ZB plus ZC into ZA ZB, sigma ZA ZB. So this is equal to ZA plus ZC by ZB plus ZC into sigma ZA ZB. Okay, let this be equation number 7. Okay, then if you divide this equation by 6, that means 5 by 6. You find out 5 by 6, that equation 5 by equation 6. If you divide Zi1 and Zi1 will get cancelled, you will get 1 by Zi2 square. Let us divide now 5 and 6 now. Zi1 into Zi2 by Zi1 into Zi2 by Zi1 by Zi2. LHS, which will be equal to Zi1, Zi2 will get cancelled. Zi2 square. To divide this by this, Zi1 by Zi2, right, Zi2 square, which will be equal to ZA plus ZC by ZB plus ZC by ZA plus ZC into sigma ZA ZB. We will get this equation, right? Zi2 square. Find the square root of Zi1 square, then you will get Zi1 is equal to under root ZA plus ZC by ZB plus ZC into sigma ZA ZB, and Zi2 is equal to square root of ZB plus ZC by ZA plus ZC into sigma ZA ZB. Okay. Finally, we got these image impedances Zi1 and Zi2. Another method also is there. By finding open circuit impedance, short circuit impedance, we can find out Zi1, Zi2. In the earlier class, I have told you, I have explained about that. That is Zi1 is equal to under root Z0, Z10 into Z20, and Zi2 is equal to under root Z20 into Z10 into Z1s, Z20 into Z2s. By using this formula also we can find out. Okay, for the two-port network, T-type two-port network, first find out Z10 and then Z1s, multiply those two and put it under root and look at Zi1. That method also we can use. Zi1 is equal to what? ZA plus ZB, ZA plus ZC by ZB plus ZC under root into sigma ZA ZB and Zi2 equal to under root ZB plus ZC by ZA plus ZC. Okay? If the network is symmetric network, then ZA is equal to ZB. If you substitute here, what you will get? Can anybody tell me? ZA is equal to ZB. You substitute here. ZA1 will be equal to under root ZA is equal to ZB, right? ZC, but ZB बदलो ZA रास्तुना plus ZC sigma ZA ZB under root. So these two will get cancelled. Finally, you will get sigma ZA ZB. Similarly, Zi2 will be equal to, if you put ZA is equal to ZB, you will get sigma ZA, ZB. Okay, these are the two impedances. When the network is symmetric, ZA1 is equal to sigma ZA ZB and ZA2 is equal to sigma ZA ZB. Now let us see what will be the image impedance for a L network now. For L network, ZB will be equal to 0. For L network will be like this. So this is L type network. L type network. Here this Z2 is equal to 0. ZA is there, ZB will be equal to 0. Okay, if you put ZB equal to 0, you will get ZA1 and ZA2 for L type network, which is asymmetric here. Okay, putting ZB equal to 0, what you will get? Putting ZB equal to 0, what will be the ZA1? What will be ZA1? By putting ZB equal to 0, let us find out ZA1 now. ZI1 for L type two-port network, ZI1 is equal to putting ZB equal to 0, you will get ZA plus ZC by ZC, since ZB equal to 0. Here you expand this, you cannot put ZB equal to 0 and put everything here 0 here. So here sigma is nothing but ZA ZB plus ZB ZC plus ZC ZA. Sorry, is it visible board for you? ZA ZB plus ZB plus ZC plus ZC ZA. ZB is 0. Okay, so only ZC ZA will remain. ZA1 is equal to under root ZA plus ZC by ZC into ZC ZA. This ZC and this ZC will go off. So ZA1 will be equal to ZA into ZA plus ZC under root. So this is the image impedance for L network. That is nothing but ZA square plus ZC. So ZA1 is equal to ZA square plus ZA ZC under root. This is nothing but ZA. Okay, similarly ZI2 will be equal to, you just substitute ZB equal to 0 in ZI2 for L type network. So put ZB equal to 0 in this, then ZI2 for L type will be ZB equal to 0, ZC by ZA plus ZC into, you expand this, ZA, ZB plus ZB, ZC plus ZC, ZA. In this ZB equal to 0, so finally it is reduced to ZC by ZA plus ZC into ZC ZA under root. This is equal to this is equal to ZC ZA by ZA plus ZC. You multiply numerator denominator by ZC ZA by ZC ZA. This ZC and this ZC will go off. Then you will get ZC ZA whole square. So there is ZI2. So look at this equation. ZI2 equal to ZC ZA whole square. Bring out from square root, then you will get ZI2 is equal to ZC ZA. So ZC ZA by root of ZA square plus ZA ZC. Which is equal to ZC ZA by under root ZA square plus ZA ZC. So this is ZI2. Okay, I am stopping here. No response from you.